To settle concepts, let us look at simple settings where the binomial arises naturally. To keep things firmly in view, we are dealing with the toss of a metaphorical coin whose success probability is p. We're going to toss it repeatedly n times. In other words, we have a sequence of n Bernoulli trials. We represent these trials by x1 through xn. We form the accumulated sum. These will represent the accumulated successes in these n trials. We call that S sub n. And we've discovered that S sub n has got atomic probabilities governed by the binomial distribution B of k, with parameters n, the number of trials, and p, the success probability. Our first example is whimsically titled. Let's call this Psychic Tendencies. The problem at hand is the following. Imagine that we have a standard 52-card deck. The experiment proceeds as follows. A card is selected at random from the deck. You are asked to guess what that card is. That card is replaced, and a random new card is drawn. You're asked again to guess what that card is. This is repeated 10 times, and you now have a sequence of 10 guesses. What is the chance that you guessed 2 of the 10 cards correctly? What is the probability that you got at least one guess right? What does your intuition say about the problem? Do you think either of these probabilities is large, small, very small? Now, you already have enough of a technical armory to be able to set up a probability space for this problem and analyze it. Give it a go. And when you're ready, restart the lecture. Well, now that you're back, let's see if we can put together a systematic analysis for this problem in the framework that we have developed so far. The simplest way of thinking about the accuracy of a guess is as follows. There are 52 possible cards. A card is randomly selected, and therefore you have a 1 in 52 chance of getting your guess right. Since the cards are replaced and sampling is with replacement, and the new samples are independently drawn, every guess forms an independent event. In other words, we have a system of repeated independent trials. Each guess being right or wrong, successful or failed, with probabilities 1 in 52 and 1 minus 1 in 52. In other words, we are dealing with a succession of 10 coin tosses, 10 Bernoulli trials, whose success probability is 1 in 52. Success here, of course, connotes that your guess was correct. Let's promptly put in place a mathematical structure around this. The guesses are Bernoulli trials, x1 through x10, corresponding to the toss of a coin whose success probability is 1 in 52. The number of successful guesses is the accumulated number of successes, the sum S sub 10 of x1 through x10. And of course we know that now this is governed by a binomial distribution corresponding to n equal to 10 trials and whose success probability is p equal to 1 over 52. And so in particular, we can write down an atomic probability, the probability that S10 takes the value k. In words, the probability that you are successful with k out of your 10 guesses is exactly the binomial probability on the right of the screen. Now we are ready to handle the individual problems that are posed on the left. What is the probability that you've got 2 guesses right? Well, this is exactly the probability that S10 is equal to 2. We simply write down the binomial probability, evaluate it. A simple calculator will do it for you. Or, if you're not feeling particularly adventurous, you could simply type in estimate binomial probabilities or a binomial calculator into a search engine on a website, and you can just type in these values and out comes an answer. your chances for getting at least 2 out of 10 guesses right is approximately 1.4%. What about your chances of getting at least 1 guess right? Well, let's begin by writing it down. The event at hand, of course, is the probability that S10 is 1 or larger. It is easiest to think of it in terms of its complement. Since S10 has to be some value between 0 and 10, the event that S10 is at least 1, together with the disjoint event that S10 is 0, in other words, you get no guess right, is the entire sample space. And therefore, by additivity, we can relate the probability that S10 is bigger than 1 to 1 minus the probability that S10 is 0. Now we simply write down the binomial probability. Evaluate it, and out comes a clean and simple answer. The probability that in 10 guesses of cards, you get at least 1 right is approximately 18%. Now, this is surprisingly large if you think about it. This says that 1 in 5 people making guesses will guess at least 1 right. Now, if one really wanted to test somebody's psychic abilities, one would test their performance against these binomial probabilities. And deviation from these binomial probabilities, of course, would then be taken as evidence of psychic behavior, or perhaps more reasonably, evidence of a rigged game where the cards are rigged.